All right, use your notes, what you learned the last week, all the methods of solving quadratics to solve these 4 quadratics, and try to use a different method for each one. So if you need your notes, go ahead and use them. Don't forget, you could graph these to see the x-intercepts. You could use factoring to solve them. You could use complete the square, and what we just learned, quadratic formula. Looking at letter A, definitely what method would be very difficult. It will work, but it will be difficult because of this. Complete the square. Why? The fraction, because the B is an odd. 5 divided by 2. So you don't want to use complete the square on letter A. Save it for another one. All right, so what ended up being the best method for A? I think there's a faster way than that. Factoring. This is factorable, especially since if you used the quadratic formula and you got whole numbers or rational numbers, that means it was factorable in the very beginning. So this is factorable, so you factor easily with positive 8 and negative 3. So what makes each of those 0? X is negative 8 or positive 3 and positive 3. B, what method would be best there? Square. Very good, complete the square. So use complete the square for this one. And when you do that, you will get x equals 3 plus or minus radical 7. Is that irrational or rational? Irrational.
The little boy.
The little square roots. The square root makes it irrational. Yes. What about C? The quadratic formula is what the book wanted you to do, but you can factor this one. It's a lot faster if you do. Whether you do it that way or factor, which I think it's a good way to do it, you would get the same answer of 1 and negative 5 halves. All right, part D here. What method would be good for this one? Factoring does work too. It would be different to 2 squares, x plus 10 and x minus 10. Or you can use square roots. Okay, square roots of this one, you would add 100. And then you take the square root of both sides, giving you x equals positive or negative 10. Okay. If you actually factor it, you will most likely not lose the positive negative 10. All right, so we're looking at a thing called the discriminant today. It's actually a special part of what we learned yesterday, the quadratic formula. It's actually the inside part of the square root. It is what makes or breaks the number of solutions in a quadratic. So we can look at that first and get a shortcut and see how many solutions we're going to get before we even start solving. It's a lot like solving systems. What do we compare when we were looking at systems and trying to classify the number of solutions? What do we compare those 2 linear equations? The slopes. So when we looked at the slopes in linear forms, we could see the number of solutions. We look at the discriminants in linear quadratics, we could find the number of solutions. So we have the standard form ax squared plus bx plus c. We're solving a quadratic, so we must have it equal to 0 in order to solve. So once you're in this form, equal to 0, identify a, b, and c, and you're going to plug it into the discriminant. So that's the inside part of the quadratic formula. So when we were doing square roots inside the quadratic formula, how do you know it was no solution? There's a negative inside the square root. Why can't you have a square root of a negative? Because there's no number times itself that will be a negative. Okay, so what's another possible result? So if we can get a negative number sometimes, right? Let me write this down. We could get a negative inside that square root sometimes. What else could we get? We get a positive. Engage what? A 0. So you either get a positive number inside, or you get 0 inside, or a negative number. Now, how many square roots are there, or how many roots are there of a positive number? 2. the positive, the principal root, and the negative evil twin. So when you get a positive number in this discriminant, because we are going to plug in A, B, and C and see what we get. Because if we get a positive number, we know right away we're going to have two solutions. Two solutions. So you evaluate A, B, C in that discriminant to see how many number solutions. If I get 0, what's the square root of 0? 0. Is it plus minus 0? No, this is why this always has a 0 will always be what? One solution. That's the hardest thing to remember here. Because a lot of you are going to think 0 means bad. 0 is okay. 0 means one solution in quadratics. When you plug in A, B, and C in the discriminant, you get 0. It's one solution. Okay? And negative is going to tell us what? No solution. No real solution. And remember, we are always referring to what as solutions? X-intercept. So how many x-intercepts does a positive discriminant have? 2 x-intercepts. 2 x-intercepts. How many for one solution? 1 x-intercept. What's special about that x-intercept then? It's also the vertex. Fun fact. What about the negative? No solutions. What does that mean? There's no x-intercepts. It does not cross the x-axis. All right, reminder on how to graph. Remember, always try to find this a very important part of the parabola. That's the vertex. So find the vertex. There's many ways to find vertex in this standard form. How do you find it? Yes, negative b over 2a. And once you have that x value, how do you find the y value? Good. You have to plug this in to get y. All right, so you have to do that on this first one. So let's go ahead and do that. So if I have, my b value is 2. So negative 2 divided by 2 times my a value of 1. What's that going to equal there? Negative 2 over 2 is negative 1. So my vertex in my first example is going to be, I'll write it right here. It's going to be negative 1. How do I find the y value? Go plug in negative 1 into the original function. What's negative 1 squared? 1. What's 1 plus negative 2? Negative 1. And what's negative 1 minus 8? Negative 9. You plug it in, you get negative 9 for that vertex y value. Now let's go ahead and plot this. Be careful, this graph is going by 2's on the y and 1's on the x. So I'm going to go ahead and plot my vertex negative 1, negative 9, about right there probably. And then how do I get the rest of my points? All right, now you have two things you can do to graph it. You can do the easy method, which I think is easy, is use the pattern of A. So part 2 here, I'm going to say 2A, pun intended there. 2A is use the A step pattern. From where? From the vertex. That's why we have to find the vertex first in order to find where to start that step pattern. Now, if you forget this and you forget how to find that A pattern, well, you could always build a table. Whether you're dealing with quadratic functions, any function at all, if you want a graph and you have forgot everything else, you could always build a table. Okay, so build a table. Now, since you did find the vertex, if you did in step 1, build the table around the vertex. Choose values above and below, to the left and to the right of that x value. All right, let's use the pattern to graph our first example here. So at -1, -9, I also noticed my original equation had a value of what? 1. So that confirms I could use that 1, 3, 5 pattern. That 1, 3, 5 pattern. So 1, 3, 5. So I'm going to go up 1 from -9 to -8 and then over 1. So there's my first step from the vertex. That's also our y-intercept that matches our -8, our c value in our equation. After I go up 1 over 1, I go up 3 over 1. Again, be careful with the scale here. And I could get the symmetry of the other ones. Should be one right there and another one right there. What's my next step up? I went 1, 3, and then 5. If I go 5, where do I land? On the x-axis, getting my roots just from graphing here. So again, I'll have those symmetry points. Go ahead and make the parabola like so. And we see how many x-intercepts. There's 2 x-intercepts. 2 x-intercepts. All right, let's find the vertex for the second equation. Again, use -b over 2a. -b over 2a would give me the vertex x value of -1. Again, same thing, -b over 2a. Again, how do you find the y value? Plug it in. Plug in -1 over into the equation. -1 squared plus 2 times -1 plus 1 will give me what value? I don't think so. Now let's see. I think you're right. It could be 0. Let's just double check. -1 squared is 1. And then we'd have -2, which is -1. A lot of you are correct. -1 plus 1 is 0. All right, so we're going to have a 0 for our y value. So comma 0. And now let's plot the vertex at -1, 0. What's my a value? Let's go back and look. A is 1 right there. A is 1. So we can know the pattern is just like the parent pattern where we go up 1 over 1. Up 1 over 1. Oops. Need to turn the pin on. There it goes. What's my next step? Up 3 over 1. So what coordinate would that be? If I go up 3 over 1, I'll be at 1, 4. 1, 4. Okay. Symmetry for the other points. I have another point right there, symmetric. And 2 steps away, I'll be at the same y value of 4 here. So there's my parabola, connect the dots, a nice U-shaped graph. How many x-intercepts does this one have? 1. It's also the what? The vertex. So we have 1 x-intercept, which ends up being the vertex. Will that always be true? If you have 1 x-intercept, will it always be the vertex? Yes. All right, our last one down here. Again, we're going to use -b over 2a to find our vertex. This vertex ends up being at, I'm going to put the letter V first for vertex. At what? What'd you guys get? -1. Good. And you plug in -1, what'd you get? 4. You should get 4 in the output for -1 here. So we're going to plot our vertex at -1, 4. And again, we're going to go back and identify what? The a value. What's our a value? 1. That's going to tell us the pattern is up 1 over 1, up 3 over 1, up 5 over 1. Let's do it. Up 1 over 1. Again, look at the scale. It's really not going to be at 6. It's going to be at 5 right there. Up 3 from that, it's going to put me at 8, or 1/8. Can I go up again? How far? Up 5. Up 5 gives me what y value? From 8 up 5 gives me what? 13. All right, let's build the symmetry on the other side. So there's that point that reflects across here from 8 and 13. And again, a nice U-shape parabola. All right, how many times does this cross the x-axis? Not at all. 0 x-intercepts. All right, that was a good reminder of how to graph. Now let's go ahead and see that we do get these type of solutions. Remember, when we solve quadratics, we should be seeing the x-intercepts. We graphed them. We see our x-intercepts. We have 2, we have 1, and we have none in this example. So now we're going to see how that is true based on the discriminant. We're going to use the discriminant to verify the number of solutions, and then we're actually going to solve them as well. All right, as we learned, the discriminant is just the inside part of our quadratic formula. So as we're looking at evaluating a, b, and c in standard form in this equation, b squared minus 4ac. So we're going to set up our discriminant for the first example here. So b squared minus 4 times a times c. So let's go ahead and identify we are in standard form over here where we have it equal to 0. So we could list our a, b's, and c's. A is 1 right here, so a is 1. There's my b value, b is 2, and there's my c value. C is negative 8. Let's go ahead and plug them in. So b squared minus 4a times c. Right now, you should be able to kind of identify that this is going to be positive. We have a positive number plus another positive number here. All right, so let's go ahead and see the value. So we do 2 squared, which is 4. And then we're going to be adding 4 times 1 times 8. We're adding 32. So our discriminant value is 36. So again, that's a positive number. We know a positive discriminant is going to give us 2 real solutions. And now let's go ahead and find those solutions. So we're looking at solving that example, x squared plus 2x minus 8. It's already equal to 0, so it's good to go. And always look to do factoring first. Can we factor this? Can we think of the numbers that multiply to negative 8 and add up to positive 2? All right, you got them? It's going to be 4 and 2, but one of them has to be negative. We're going to make negative here and plus 4 there. That should factor out correctly. Now we're going to solve for each of those to equal 0. So remember, when we factor, we set each factor equal to 0, and we solve that simple equation. That's going to be negative 4. We subtract 4. For the other equation, it's going to be x minus 2 equals 0. We add 2, and we get x equals positive 2. And there's our 2 solutions that we saw would be true, our 2 solutions from our positive discriminant. And we also can back that up on the graph. We see it cross at those values, negative 4 and positive 2. All right, let's go ahead and solve the last 2 examples. And again, we're double checking. We should get 1 solution here when we solve the second example. And at the bottom, we should see a no solution occur in our solving. So let's see what happens. Okay, identify A, B, and C for our discriminant. So A is 1, B is 2, C is 1. Let's go ahead and plug it into discriminant now. B squared, 2 minus 4A times C. All right, now we get something here that's going to be 4 minus 4. So our discriminant value is 0. Remember, a 0 discriminant does not mean no solution. It means actually 1 solution. 1 solution. So scroll over, put down a 1 for 1 real solution. And now we're going to verify it by solving. All right, factoring is another good choice for this one. In fact, we're going to use factoring and square roots because this is going to actually factor into a perfect square binomial. Because what we have here is a perfect square trinomial. So it's going to be x plus 1 times x plus 1 to build that original trinomial. And again, when they're the same, we could write it as x plus 1 squared equals 0. Now let's use square roots to solve it. So that means we're going to take the square root of both sides, canceling out that square, breaking out x plus 1. And the square root of 0 is 0. It's not plus or minus. There's no positive or negative 0. It's neutral. So our last step now is to subtract 1 from both sides, and we will get x equals -1. Only one solution, and that is -1. So there's our answer, and that verifies again what we got over here and on the graph. Let's scroll over and see. We should be crossing at -1 on the x-axis, and there it is. There's our x value -1 on the x-axis, which is also our vertex. All right, last one now is to solve and make sure we are having no solution in the last one. So let's go ahead and scroll down there. Again, find the discriminant first. So let's go ahead and set it up. B squared minus 4 times A times C. And let's go ahead and identify our A, B's, and C's. A is 1, C is 2, or sorry, B is 2, and C is 5. All right, so go ahead and plug those in. B squared minus 4 times A times C. So you should be able to see right now that we have a bigger number on this part versus this part. We are going to have a negative number that comes out of this. Let's go ahead and verify that though. 2 squared is 4, and we have -4 times 1 times 5, so 4 minus 20 is going to give us -16. -16 is a negative number, so we know negative discriminants will always be a no real solution. So we're going to write that down over here. No real solution, because that's what we got in our discriminant, was a negative number inside our square root. Now we're going to see that negative pop up when we solve this. So let me zoom in. All right, so our equation is x squared plus 2x plus 5 equals 0. This one we can't factor. There's nothing that multiplies a 5 and adds a 2. So we're going to be stuck with either complete the square or quadratic formula. Let's use a quadratic formula. All right, so now, even though it'd be better, right? It would be better for complete the square. Let's practice our quadratic formula. So we're going to set up our x equals huge fraction bar. And remember, set these up empty, so -b plus or minus the square root of b squared minus 4ac. Remember, that's our discriminant, right? We already have this value. It's going to be -16. We know that. All over 2 times a. All right, so let's go ahead and identify our a, b's, and c. We already did that earlier. So b is 2. That goes there and there. Our a value is 1, so 4a and 2a on the bottom. And c is the last thing over here, 5. So up top, we're going to simplify. We'll have -2 plus or minus. Inside here, we already did this. 4 minus 20 is -16. There it is. Let me put that in purple, actually. Kind of remind you that's the same thing we got in our discriminants. All over 2. Now we stop here because we've learned we cannot take the square roots of negatives. This right now breaks the solution. So we'd say no real solution. And that does verify what we have in our graph, because if it has no solution, it has no roots, which means it has no x-intercepts. If we scroll over to our graph, we're going to see our parabola does not cross at all. Our parabola is opening up from the vertex, never will hit the x-axis. It has 0 roots, no roots. All right, I hope this helped. Study hard for your quiz. And good luck, and may the math be with you.